So as everybody here probably is aware, and those watching are aware, as a community, we work to quantify the lived experience of rare disease, and we published those results in 2022. And what we found was that in 2019, the economic impact of living with a rare disease was close to $1 trillion. But what had happened at that time is we were just scratching the surface. That was just the tip of the iceberg. What we had quantified was the lived experience of 379 diseases of the 10,000 rare diseases, and reflected an estimated 15 million Americans, not 30 million Americans, who are estimated to be living with rare diseases. And we knew that that was a super conservative estimate. So what we wanted to do was begin to look beyond the surface and start to look under that iceberg. What else was there to learn? What else could we quantify in the rare disease experience? So what we started to think about was the diagnostic odyssey in rare disease. Because one of the things that was required to participate in that survey that helped inform that study was that you had to have a confirmed diagnosis of a rare disease that had an ICD code. And for many of us, we know that that is a significant hurdle in our rare disease community. But we had the insight and foresight to collect some data within that study around those participating in that survey. And we had worked with the Undiagnosed Diseases Network out of NIH to help collect that data within the survey. So I want to talk about what the Diagnostic Odyssey is, and we have some folks here who are going to really help bring that to light for us here today. But to define that, so you understand what we're talking about here today, the Diagnostic Odyssey is a term that we use very casually here in the rare disease community, but it is not a casual term. And it talks about the time point between those first symptoms that first take you to a medical provider to seek out help and understanding for what might be happening in your life, your loved one's life, your child's life. That time point to the time point where you have a confirmed diagnosis that helps lead you to appropriate medical care and appropriate intervention. And it helps encapsulate everything that happens in between. And there is so much. And while this image seems like a pretty straightforward path with hospitalizations and ER visits and diagnostics, it oftentimes for many people is untenable, really looks more like the game board from Chutes and Ladders, and sometimes is unending. But for us in this study, the first study that we conducted, we actually had some data for those who had participated in the study. And what we knew was that for those who had participated in the first study, for the first time we had some data around the mean diagnostic odyssey in the rare disease community was over 6 years for those with a confirmed diagnosis with an ICD code, and included more than 17 providers. So we wanted to dig deeper and start to understand what that could mean. We also had an understanding of who those providers were, what those interventions included, how many of those were out-of-state visits. And many of us also understand that that comes with a lot of insurance privilege to be able to go out of state to seek medical care and a provider, to be able to be reimbursed for that care, to be able to have your caregiving costs covered while you go with the child or the loved one and seek those insights. So we wanted to understand what some of those costs might be. So that's what brought us to this study. So here's what we know about the Diagnostic Odyssey before we began. We know that the Diagnostic Odyssey results in delayed and misdiagnoses. We know that delays in an accurate diagnosis can and does yield inappropriate clinical management, unnecessary medical interventions, and missed treatment windows for therapeutic interventions to optimize health outcomes or prevent disease symptom onset. Oftentimes, approved therapies are sitting on the shelves, and patients who will benefit from them are not identified or are not identified in time to benefit from them. Ultimately, a diagnostic odyssey puts patients at risk for preventable death and disability. But we also know that we have the technology to do better. We know that advancements in technologies to screen, diagnose, treat, and manage rare disease have the potential to dramatically shorten and even eliminate the diagnostic odyssey in rare disease. But we know that one of the primary barriers to this implementation is often resources and cost. So that's why we did this study, to understand, well, what are the costs involved in the diagnostic odyssey? And could we begin to work on policy that would eliminate those costs so that we could look at investing in eliminating the diagnostic odyssey overall? So for this study, we wanted to provide an estimate of the potential cost savings that may result from shortening or eliminating the diagnostic odyssey. We wanted to understand the patient journey prior to diagnosis and then quantify those medical costs. And we created a new methodology for understanding the productivity losses of a delayed diagnosis. So in short, we started to peek under the surface of that iceberg and examine just a chip of that iceberg. So we published today that report. It's on our website. You can go there for all of the methodology and all of the details. You don't have to be able to read the slide, with the exception to tell you that we included a robust data set that includes public and private data sets, so Medicaid, Medicare, and commercial data. We used the ICD codes of the diseases that we included in this study. And unlike in the first study where we were looking at a broad universe of rare diseases, we chose 7 specific diseases to look at to develop a methodology and to use as case studies, if you will, so that we could extrapolate those to the broader population. And while this is Newborn Screening Awareness Month, so we're really focusing today on the pediatric diseases that we included in this study, we are not only interested in solving the diagnostic odyssey for pediatric disease. So of the disorders that we included, we had 7 diseases. The 5 highlighted in red here are the pediatric onset diseases, or traditionally pediatric onset diseases. We had 2 traditionally adult or later onset diseases. And the 3 that are bolded are those for which there are already federal recommendations to the Federal Newborn Screening Panel, so that we could look at the impact of newborn screening versus the cost that would be incurred without newborn screening in those diseases. In order to do this, we created very detailed patient journey maps. So we worked with an expert advisory committee who guided the overall study. And then for each of these 7 diseases, we had another deeper layer of experts in each of those diseases who helped us understand what the patient journey would be for an ideal timely diagnosis versus what the patient journey looks like in the typical clinically presenting diagnosis. Again, that guided this study. And we thank everybody who was involved in this study. We utilized and relied on those groups heavily throughout the time period. As I mentioned, there was also a formula developed for calculating productivity losses. I will say the term I use for this is it is grossly conservative. It was really important to our health economic team that this be anchored to validated methodology that had already been published. But this in no way actually reflects what happens in a rare disease journey. And so we put that caveat over all of this. But as with all of the data that we push out, we want it to be bulletproof and we want it to be defensible. But we understand that in rare disease, your providers are not across the street, that these visits are not usually half a day or a quarter of a day. But this data is a start for us as a community. So this is where we are, and I'm getting the flag. So I'm gonna wrap this up, but we do have infographics for everybody, and I'm gonna show you just a sneak peek of where we are. This is an overview of the cost of the diagnostic odyssey for the pediatric diseases. What you have on the left is the cost of the diagnostic odyssey, the timely diagnostic odyssey, the mean age of diagnosis for each disease. So it is specific to each disease. And then on the right-hand side is what the mean age of diagnosis and what the cost of that diagnostic odyssey would be in a delayed diagnosis. Again, specific to each disease. So when you look at this and you orient yourself, you compare sort of color of the bar to the color of the bar and look at that difference. If you had a timely diagnosis versus a delayed diagnosis, what that cost difference would be. These are avoidable costs. These are not necessary costs if we were to implement the tools, resources, and technology we have to have timely diagnoses in these diseases. Looking at this another way, if we look at the 3 conditions for which we have newborn screening available, this is the comparison of those costs. For ALD, Pompe, and SCID, and we have representatives from 2 of those communities here today, these are the avoidable costs in the diagnostic odyssey for ALD, Pompe, and SCID. Out-of-state trips related to rare disease diagnosis. Again, a very conservative estimate. On the left-hand side, this shows for children, so if you're seeking a diagnosis for a child, the mean number of out-of-state trips based on the length of the diagnostic odyssey. So if your odyssey is between 2 and 4 years, the number of out-of-state trips was just over 4. If your diagnostic odyssey was more than 5 years, there were more than 5 out-of-state trips to seek a confirmed diagnosis. On the right-hand side, you see the data for adults. Again, this is only if you can actually seek out-of-state care, if you can afford to do that on your own, if you have insurance that will reimburse you for that. If you don't, your diagnostic odyssey would be much longer. So there are infographics available on our website. Those of you in the room have these. What we have done is we have taken all of these data and we have pulled them down for each of the diseases in the report. For 2 of the diseases, we've put them together as infographics, and then we have a combined infographic. What you'll see, just to orient you to this, is what we've done is shown on the right-hand side for a timely diagnosis, the number of interventions as they expand out from the center in a timely diagnosis versus a delayed diagnosis. With a timely diagnosis, the visits to specialists, the number of testing procedures, the number of treatments and supporting therapies, and the number of events are going up with a delayed diagnosis versus a timely diagnosis. When you have a timely diagnosis in both Duchenne and Pompe, the 2 infographics that we have here, none of these are needed during the pre-diagnosis period. We also have the aggregate costs for all of these visits. And then I'll just show the combined, and I'll end on this. What we have shown is that the avoidable costs across the 7 diseases range from $86,000 a year to $517,000 a year. These are the avoidable costs of the diagnostic odyssey per patient. Study limitations, of course, we were limited by ICD codes. The majority of rare diseases do not have an end to the diagnostic odyssey, which my friend Sarah will talk about today, so the cost would be much greater. And the productivity loss methodology was super conservative, so the costs would actually be much greater. I want to thank everybody who made this study possible. It would not be possible without our extraordinary community and all of the experts who made this work possible. And we call on all of you here today and around the globe to help us implement this and implement these solutions. Thank you.
My name is Paloma Juarez. These are our 3 sons, and I'm truly honored to be here today to talk to you about our family's diagnostic journey. My husband, Brian, and I were actually dating and having a long-distance relationship when we found out we were expecting. We looked at a couple of different places, states more glamorous than the Midwest, but finally we decided to set up home in my hometown of Kansas City, Missouri. We actually moved to a suburb called Overland Park and discussed should we move my doctor from 20 minutes away in Kansas City to closer to the apartment. And after much battling from a stubborn pregnant lady, we decided not to. So that ended up being a detail that would change our lives forever. This is Vaughn Sanford Way. He was born on May 28th, 2016 in Kansas City, Missouri. I love that chunky kid. At 7 days old, we received a phone call saying, hey, your son has been flagged with his newborn screening for something called Pompe. Please do not Google it, as this is brand new technology. At the time in 2016, Missouri was only 1 of 5 states screening for the disorder, and so they were pretty sure that this was just a false positive. 2 days later, we met with a genetics team and a cardiologist. We had blood draws, an echo, and what we found was that Vaughn had elevated CK levels and hypertrophic cardiomyopathy. Our world was shattered, and we had a diagnosis of not just Pompe disease, but an extraordinarily difficult form of Pompe. So what is Pompe? We Googled it before we had gotten off the phone, and the only thing I really remember is that bottom part that says it leads to death from heart failure in the first year. I still get emotional thinking about those feelings. We took our son home and we began researching. How do we find a plan to save him? Because this cannot be his story. Oh no. So with a 9-day diagnosis, we found a study that talked about best outcomes for children with his diagnosis was to begin enzyme replacement therapy within the first 30 days of life. But that seemed really impossible traditionally because children weren't diagnosed till, at minimum, the first month, but generally within 3 to 4, and a lot of damage could happen by then. Our community has a saying that time is muscle, and every single muscle can and will be affected and is vulnerable. So we pushed and we fought, and at 23 days old, Vaughn Way started enzyme replacement therapy. We were hopeful. We thought that because we have done this, maybe his life and story would be different. This is him and I at the hospital with his dad getting port placement, a really tricky time. But we made it to his first birthday. He was meeting milestones, he was growing, he was thriving, but we knew there was still more that we could do. And so we finally reached out to our Pompe community and attended our first pediatric Pompe conference at Duke when he was 2. And what we found out was kind of devastating. Vaughn's story, while amazing for us, was not the typical one. We met 2-year-olds that were using wheelchairs, whose parents were feeding them with their G-tube while we were just chatting casually at a table. There were children that were second born to their family because their older brother or sister had succumbed to the disease. And so we felt a certain amount of guilt because how could Vaughn's story be so drastically different when we're talking about even 6 to 12 weeks difference of starting enzyme replacement therapy? And we knew that this was important details. Challenges for Vaughn were he really had issues with those oral muscles. So things that help you talk, things that help you chew, things that help you laugh or giggle. Those were all hard for him. And so we continued therapy. We found services to help him learn how to eat orally, and he just continued to learn and move on. Let's see if this wants to play. Oh, it doesn't. So in 2020, we found out we were expecting twins. They were fraternal, so we knew that each of them were going to have their own odds of having the disease. So at 20 weeks, we scheduled a double amniocentesis, and we found out that baby A was positive for Pompe, had the exact same mutation and disorder as Vaughn, and baby B was completely not affected, not even a carrier. Cohen Peter Way and Xavier Daniel Way, we welcomed them at 37 weeks on August 17th of 2020. We had learned from Vaughn and the community that we needed to keep pushing the limit. So our goal was, can we start him with enzyme replacement therapy at a day old? Only that was a little hard to do because there were 2 babies in there, and we needed to make sure we were doing this with the right one. So at 3 days old, our other little chunky baby started his road with enzyme replacement therapy. He was 20 days younger than Vaughn. And wow, did he grow. He was thriving, and he continues to learn. We have a weird science experiment going on in our house, as we not only have 2 kids with Pompe that started at different times, but Cohen and Xavier are twins. So there's always this interesting aspect of seeing how one develops against the other. And truth be told, lots of times, Cohen's a little earlier than Xavier. He is the talker, the singer, the incredibly outgoing one of our crew. So what does this mean? Well, for starters, time is muscle. We learned that even not just enzyme replacement therapy in 30 days, but enzyme replacement therapy within those first few hours. We knew because of a diagnosis with Vaughn, we started looking at different things, and actually the hypertrophic cardiomyopathy begins at 32 weeks gestation. It happens. We are seeing muscle damage that early in the 3rd trimester. So not only was it critical to start things as soon as possible within that first month of life, it's incredibly critical, can we start before birth? And what can we save because of that? I think that when you think about in terms of what muscle would you be willing to sacrifice? Would you maybe not want to eat your favorite food so that you could hear a bird chirping? Would you give up walking in the sunshine so that maybe your arms work to hug somebody nice and tight? Would it be okay for your son to have speech issues if it meant they could walk around and jump on the playground with people? All things that we've considered, all real things that happen to families who have a delayed diagnosis. Newborn screening not only saved our children's lives, but it gave them opportunities that we thought weren't possible. Today, Vaughn actually is in 2nd grade. He stood up just like I am, talking to his fellow classmates, telling them his own presentation about Pompe disease and what that means to his life. And I couldn't be prouder of him. I think the most important thing that I hope that you guys understand is while we had guilt about having a diagnosis the way that we did and how different their lives were compared to the majority of people in their community, we feel grateful because somebody somewhere stood up one day just like this and said that newborn screening for Pompe was possible. I encourage all of you to continue to think about the fact that we can still do better. Can every story not just be like Vaughn's, but can every story be like Cohen's? And that's what modernizing newborn screening will do. So thank you.
Again, thanks for inviting me here today. I have the distinct privilege to serve as on the Energy and Commerce Committee, but also a senior member on the Health Subcommittee, as well as serving as the co-chair of the Rare Disease Caucus here in Congress with my friend and colleague, Doris Matsui. And we do things in that particular committee, especially in a bipartisan fashion, believe it or not, it's true. It's my pleasure to address this important briefing topic called Delayed Diagnosis in Rare Disease, the economic costs, personal impact, and policy solutions. For me, this work is very personal because I've known many close friends and constituents and relatives who have and continue to suffer with rare diseases. I've since, again, I know the costs, the financial terms, but also the human toll that battling a rare disease inflicts upon the patients and his or her loved ones. That's why I'm inspired by the incredible work of you all. Again, we appreciate your advocacy, and it makes a real difference. It does. The rare disease patients, and as I said, advocates, you are determined to empower those suffering with a rare disease and ensure their voices are heard. Rare diseases, as you know, are not a rare problem, and millions are affected by rare disease, but many may not even know they have any type of rare disease. That's why this really this movement is so very important, particularly with the newborn screening. With each rare disease impacting smaller patient populations, there are challenges in getting the research and attention each of these patients deserve. That's why, again, the new report by the Every Life Foundation, it's really very important that we're having this discussion today, as it talks about the cost of delayed diagnosis in rare disease and the economic impacts it collectively has on patients and, of course, the rare disease community. Many of the costs associated with rare diseases are avoidable, which is why it's so critical to focus on early screenings, and particularly newborn screenings, since delaying diagnosis can lead to significant costs in the system. We have the opportunity to take a more proactive approach to battling rare diseases. We all want to promote healthier babies and to prevent a child from suffering whenever possible. Early identification and intervention dramatically it improves health outcomes for all these children that are born, unfortunately, with rare diseases. In addition to simply being the right thing to do on a human level. The newborn screening program saves taxpayer funds and deferred costs of treatment if the condition was left undetected. The newborn screening program, common sense, is one of the most notable public health success stories. We must ensure the continuation of this effective program while embracing changes that will allow it to better keep up with the rapid pace of medical advancement, particularly in the field of diagnostic testing. As policymakers, we all talk broadly about the need to empower patients and promote a patient-centered healthcare system that allows for individualized care. One of the most powerful tools for achieving this goal is the advancement and availability of diagnostic testing. I'm strongly supportive of these policies. As far as I'm concerned, it's a no-brainer. These policies will help incentivize accurate diagnostics as early as possible so we can identify and start to treat rare disease patients sooner and more effectively. We must ensure vital tools such as the newborn screening program are accessible to our most vulnerable citizens and invest the resources needed to ensure it continues to fulfill its potential. Talking about it both in human and economic terms is helpful for lawmakers, such as myself, to better understand how we can continue to focus on helping patients in need. Again, back in the old days, we didn't have access to this newborn screening, and a lot of kids suffered. And they didn't get diagnosed till later in life. And we just can't have that happen, folks, particularly in this day and age. Rare diseases, as I said, are not a rare problem, but we don't have cures or treatments, I believe, for 95% of these diseases. And that's got to change. That's got to change. This needs to be a priority. It is a priority, and we do work in a bipartisan fashion in the Energy and Commerce Committee, and we have a great conference. But the Everyday Life Foundation does an outstanding job bringing attention to it and advocating. And we've worked together for several years now, and I think we've accomplished quite a bit, but we have much more to accomplish. These children matter. They matter a great deal. And again, economics is secondary, but it just makes common sense. We're going to save money in the long run, but quality of life is even more important. So thank you very much for having me here today. God bless you. And again, God bless this wonderful organization, because y'all make a difference. Thank you.
My name is Sarah Marshall. I have 4 daughters, and I live in Minnesota. I hold a master's degree in social work, and as Dwayne said, I work as a medical case manager for women and children living with HIV. My daughter Phoebe was accepted and evaluated by the Undiagnosed Diseases Network, and I've served on UDNPR since 2018 and been co-chair since 2022. Phoebe was accepted into the Undiagnosed Diseases Network in 2017, as was said, and the UDN, for those that don't know, is a research study that is funded by the NIH, and its purpose is to bring together clinical and research experts from across the United States to solve the most challenging medical mysteries using advanced technologies. Being accepted into this study changed the trajectory of her life. And you may ask, how did it change her trajectory? simply because she got a diagnosis. Because without a diagnosis, there is no treatment, and without treatment, there is no hope for a better quality of life. So I'm going to begin this presentation with the diagnosis part of her story. A de novo missense variant of GDF11 was identified by the research arm of the UDN. The diagnosis opened the door to precision medicine that has improved her quality of life and allowed her to live as a typical teenager. In this paper, identifying loss of function variants of GDF11, 6 cases were described with variable but overlapping clinical symptoms. The clinical symptoms involved intellectual disability, cognitive delay, seizures, neurological abnormalities, visual disorders, hearing disorders, craniofacial anomalies, palate anomalies, vertebral anomalies, scoliosis, toe abnormalities, connective tissue abnormalities, and cardiac abnormalities. Of these 13 clinical symptoms, Phoebe had 9. She is programmed 6 in this study. Now let me start at the beginning of her story. This is Phoebe, born healthy in 2008, youngest of 4 sisters, all of whom to this day are very close to each other. Oh, they really are. Phoebe's diagnostic odyssey began at 6 months old with a bout of pneumonia. Subsequent to that, she began having respiratory infections about every 30 days that required antibiotics. At 2.5 was her first hospitalization. Joint pain and skin rashes started at age 2, vision problems and headaches at age 5, liver inflammation at age 6, fatigue, weakness, abdominal adhesions, bone and spine anomalies identified at age 7, encephalopathy at age 12, followed by depression and anxiety. And in total, she's had over 20 surgeries and multiple hospitalizations from ages 2 to 13. It was always something. These are some photos from some of her early hospitalizations. Here, she's 6 years old. Here is a photo of a diagnostic test that was done on her retina. The bright spots along the blood vessels show where fluid is leaking out. The tests were done because she complained of seeing black spots in her field of vision for weeks on end. She was 5. Some skin manifestations that have occurred over time. Here along her entire shin looked like a bruise, but wasn't. Doctors thought this might be scleroderma, but a skin biopsy proved negative. I was advised by her physicians to take photos when something new happened. Here, she woke one morning with redness and swelling around her eyes. Her skin can display these lesions when exposed to the sun. After testing, her dermatologist has rendered this a porphyria-like manifestation. This is a photo of scar tissue that forms between her cecum and her intestine, always causing pain. Her surgeon lyses the adhesions, as seen in the picture on the right, and her pain is remedied. For this, she has had 9 surgeries since 2015 and 2021. This is a photo of spinal fusion to fuse L5S1, where she was having pain for over a year. We decided to go ahead with spinal fusion after extensive imaging was done, and interventional radiology was able to confirm the source of her pain, and no other options to ameliorate her pain and improve her quality of life proved effective. Making this decision was not done lightly. She was 11. Weeks later, a post-surgical infection landed her in the hospital for an additional 3 weeks. Hypogammaglobulinemia, retinal vasculitis, liver inflammation, arthalgia, recurring abdominal adhesions, myasthenia gravis, Bertolotti syndrome and scoliosis, encephalitis, and depression and anxiety. Over time, Phoebe has received what I call siloed diagnoses. Siloed because sorry. Siloed because most of them are rare or ultra-rare in and of themselves, but none came together to offer a unifying diagnosis. Specialist seen. I'm not going to read this list because that's beside the point. Look at how long it is. And it doesn't include all the emergency doctors and inpatient hospitalists that we've seen over the years. What is the financial cost of a list like this? And what does it do to a childhood to have to be seen, poked, and prodded by so many people? The cost is incalculable. Here is our real-life costs for our family. Prior to Phoebe's diagnosis, her insurance claims per year ranged between $700,000 and $1.2 million per year. I was unable to join the workforce for years because of the frequency of her illnesses, and from kindergarten until 7th grade, she missed an average of 65 or so days of school. Since her diagnosis, her insurance claims have nearly halved of what they were. I've been able to hold full-time employment, and her days missed are about a third of what they once were. Had Phoebe been diagnosed 10 years or even 5 years earlier, this would have saved the insurance company millions and would have allowed me to re-enter the workforce and given back more of Phoebe's childhood to her. Sorry, let me go back. Currently, she receives monthly infusions for myasthenia gravis, and based on her genetic diagnosis, Precision Medicine was able to recommend an already FDA-approved medication that thus far has ended the cycle of her recurring adhesions and therefore eliminated the need for frequent surgeries. Additionally, she takes daily medication for myasthenia gravis, depression, and anxiety. Her treatment has vastly improved her quality of life, and today she engages in very typical high school activities. Examples of all the normalcy because she receives treatment. This summer, she got her driver's permit. She went to camp with her sister. This is her first day of sophomore year. And my hope is that this paper will help physicians, insurance companies, policy, and lawmakers recognize the imperative need for a timely diagnosis as a means for cost reduction over time, decreased mortality rates, and improved quality of life. Newborn screening has the ability to catch so many diagnoses so early. And beyond newborn screening, I hope this paper highlights the importance of collaboration among specialists, demonstrates the need for genetic testing, and helps insurance companies imagine the savings that can be had if they were to fund research-based genomic sequencing and other advanced technologies that would make way for both diagnosis and treatment for ultra-rare patients like Phoebe. Thank you.
Hi, everybody. So I'm going to start out with one of those perfect days that sometimes we have in Nebraska. So 30 years ago, this is my firstborn, Joey on the right, sitting next to his two cousins, one was born a few days before and one was born a few days after. So what an amazing time for me. I was 26 years old, in the middle of a PhD program, and welcomed my first son. Little did I know there was something wrong with Joe. Something just wasn't right. He wasn't gaining weight. He was battling colds from just the first days after he was born. And so his diagnostic odyssey started just days after his birth. Little did I know, and I probably wouldn't have had him sitting on the ground, sitting next to other babies, he had the bubble boy disease. So on the left is the iconic photo of David Vedder, who was born with severe combined immune deficiency. SCID is fatal if it's not treated in the first year of life. And again, I'm probably smiling more than I should have been at that time, but we were lucky in the course of SCID to get a relatively early diagnosis. Because as I click through these pictures 30 years ago, we often, with children with immune deficiencies, spent over a year in the hospital. So you can see Joey's first year as he wore different clothes for 4th of July, Halloween, Christmas, and his first birthday. But we were very lucky. We got a relatively early diagnosis, and being in medical genetics, I knew how to do a literature review. We were able to go to a transplant center. We were able to get relatively early care. So with Joey's treatment, we thought our family is back on track. We've got an immune system. We left the hospital with just half of an immune system, but we thought we'll take it. But once we got home, Joe continued to have some developmental concerns, and because of all the medical procedures and the infections, so when he was sitting next to his cousins, I didn't know he already had 6 bacterial and viral infections attacking his little body. So once we got home with half an immune system, we saw some developmental delays. We actually moved across the country again. And that move across the country, I was able to continue my PhD studies and actually be part of the Human Genome Project. We were in sunny California, and they provided some early intervention for kids like Joey in those days. So I was very lucky. Because of my work in the human genome and some early ideas I had about how to combine informatics with genomic variants to help us understand diseases, I was appointed to a federal advisory committee on heritable disorders in newborns and children by President Bush. This was my first introduction to the newborn screening system, and a light bulb went off. I thought, what an amazing opportunity to pre-symptomatically identify newborns, treat early before those consequences, before the loss of muscle, before the first infection, before the loss of brain cells. Let's do something early. Let's leverage this population-based screening. And so for the last 13 years, I've been part of the American College of Medical Genetics and Genomics, leading a key initiative at NIH called the Hunter Kelly Newborn Screening Research Program. Another president, other than President Bush, President John F. Kennedy, called on NIH to create the Eunice Kennedy Shriver National Institute of Child Health and Human Development. And for the last 15 years, they've funded ACMG to advance discoveries in newborn screening. So I've been really excited to be part of this group and to run a team that has really worked to advance novel discoveries in screening, diagnosis, treatment, and management. But what I've learned through my personal experience and my professional experience is that it doesn't end with screening or a diagnosis, that we have to make sure that we take care of these children and families throughout the life course. And I think I made this little picture of Joey's first years. So when you look at the report, amazing report by the EveryLife Foundation, for SCID it's a little bit different. If we can identify in those early days after birth that there is an immune deficiency, we can do a whole lot in the beginning so that we can actually replace that immune system. We can avoid the infections, we can avoid the neurological damage, we can avoid all the other consequences of this disease if we intervene early. So this picture might only have a few icons on it. So in closing, I realize I'm so lucky. This is Joe with his 2 twin siblings, and our story is unique. And again, we're so fortunate. But the medical costs for rare diseases, as we've all heard earlier, are inevitable, but they're avoidable. Joey's delayed diagnosis is today avoidable. But the care and diagnosis and management of children with SCID is not covered. We mandate newborn screening in the United States, but we don't mandate care. And so we really have a lot of work to do, and I'm so glad to be here today and have this unique opportunity to impact the lives of every newborn born in the United States, regardless of geography, economics, and the parents' and community's ability to take care of them. So thank you so much for the opportunity today.
Obviously, the people in this room are very familiar with the term diagnostic odyssey. I think that the general public is actually starting to get a little inkling of it, although sometimes it's couched in other terms like medical mysteries. That they see that on TV, they see it in the newspaper. In fact, the Washington Post has a medical mysteries column that they run periodically. I'm very proud to say that there was a medical mystery published the other day that featured an NIH researcher who was very key in solving that. So I was very happy about that. At the NIH, we've heard about the diagnostic odyssey for many, many years. We work quite a bit with the rare disease community, and we'd heard about it. We'd never really been able to quantitate what was going on until about 2007. And what we did at that point was to take a look at all the inquiries that were coming into our Genetic and Rare Disease Information Center, the GARD Center that many of you may have heard about. And these come in by phone call, by email. Sometimes they come in inquiries on the website itself. And what we found was that about between 6 and 7% of the hundreds of monthly inquiries that we were getting were from people who were on this diagnostic odyssey. And at that point in time, this meant that there were thousands of people who had come to us looking for help on their way. And it wasn't that they didn't necessarily have a diagnosis, but what happened was they had an incorrect diagnosis, and then they would get an incorrect treatment, an ineffective treatment, and then the cycle would begin. They would go and try to get another diagnosis. I mean, many of these people were sending us their medical files for any type of help. Despite the obvious lack of privacy. The cycle really needed to stop. So at that point, the leadership in our office met with the leadership of the NIH Clinical Center and researchers at the Genome Institute, and that was really the beginning of the Undiagnosed Diseases Program. And then the Undiagnosed Diseases Program eventually morphed into the Undiagnosed Diseases Network, which you heard about a little bit already. But one of the other outcomes from this analysis, beside the UDEP and the UDN, which obviously was significant, was for me personally, it really crystallized this idea that there's a difference between treatable and actionable. And obviously, treatable is the endpoint that everyone would like to reach. And it's a requirement for the RUSP. If you're in newborn screening, you have to have a treatment before you can get on the RUSP. But for many in rare diseases, and especially for many of those who are in the undiagnosed pathway, really what they are looking for is actionable information. Being able to end that diagnostic odyssey is an action. Stopping the inappropriate treatments is an action. Being able to figure out how this impacts children, their families, is an action. And all of this is critical to being able to move on with their lives. I want to skip a few things since I don't have too much time. So obviously the short-term goal of the Undiagnosed Diseases Network was to learn how to treat or diagnose people faster and as early as possible, but eventually to even try to figure out how we can do this when patients are pre-symptomatic. How do we get ahead of the curve? The reason this is important, I mean, we heard a little bit already, but I have one colleague who is in the rare disease space who has a child who was at the time they were diagnosed, it was the youngest child ever diagnosed with this disease who didn't have a sibling with that disease. And it was a very astute pediatrician who noticed some things of concern and then moved them on to a specialist, and they were diagnosed early. There was no treatment available for this disease, but one of the hallmarks of the disease is deafness, acquired deafness. They were able to get the child fitted for hearing aids at a very early age so cognitive development could continue. There were also behavioral issues that are typically seen. They were able to get behavioral therapy, which not only meant a better life for the child, but a better life for the parents. None of these get to the underlying pathophysiology of the disease, but they do make the family and the patient that much happier. Another example is from the Undiagnosed Diseases Network, where one of our participants was diagnosed. They went on and then tested the participants' children and found they had the same thing. They were able to then follow these children to be able to monitor them so that they can go ahead and begin treatment at a point that will make sense before they start coming across any of the negative things that brought them to the UDN. Ultimately, the purpose of the UDN is to really to put itself out of business. The goal is to develop these diagnostic processes, to spread them to other researchers, to other clinicians, so that we can be able to more easily research, and the diagnostic before it even stops. There are a number of programs that NIH has that will help with this. The RDCRN, the Genome has a number of programs too. And hopefully in the future we will be able to develop several other programs that will help end the diagnostic odyssey. Thank you.
Again, my name is Dylan Simon, and I'm here to talk to you about newborn screening and newborn screening policy. So we've heard a lot today about the promise of newborn screening, and it really is generally considered one of the most successful public health programs in the country, but it's not without its challenges. And so today I want to talk a little bit about some of those policy areas that we can look at to potentially improve newborn screening, while also acknowledging some potential avenues to do that. So here you can see some of the challenges within the newborn screening system, but the part I want to highlight is the part you see on the right side of the screen, which is in a 2021 study from RTI International. When surveying a wide variety of newborn screening experts, 100% said changes were needed to meet the system, and that newborn screening system was not addressing all the current challenges that it was facing at the moment. And within that 100%, 45% said they needed a large change. So 100% said some change was needed, and at least almost half were like, we need to really be thinking about large-scale changes. And so that's what has really led the community over the last few years to really have some larger conversations about how can we ensure the fact that the system is growing and moving forward to address the challenges that it's going to face in the 21st century. So that's what led to a group of organizations that you see on the right side of your screen to come together and bring the community together as a whole to begin to address some of these challenges. We wanted to make sure that we were bringing together the entire community, not just patient advocacy organizations, not just industry, not just state lab directors, but everyone together talking as a collective amongst each other, including state lab directors, federal officials, academic researchers, to make sure that we were approaching the challenges from all perspectives. I'll talk a little bit about that when we get into the final theme. This idea of making sure that we weren't proposing policy solutions that could not be implemented, because the key part we've heard today is actionable policy solutions. How do we ensure the fact that what we're talking about can actually get done? And so the planning committee brought together the roundtables, which consisted of 3 events, the first of which was a public event, because we wanted to make sure we were hearing from the entire community. And then we brought in, for the final 2 events, a bit smaller, but again, wanted to make sure we were engaging the entire landscape, so patient advocacy organizations, state lab directors, industry, as well as federal officials, academic officials, and other state officials, to make sure that when we were talking about the solutions, we heard all points of view. And so we really came into 4 key themes, and so I'll walk quickly through them now. I also want to highlight we had released this white paper last week, so a full understanding of all the policy solutions you can find online. And so today I'll focus mostly on the themes themselves. And so you can see here with theme 1, it really looks at the federal government. And this idea that federal agencies play such an important role in connecting the newborn screening ecosystem and must increase their leadership within the newborn screening space to support the states in their work in adding conditions, as well as ensure the fact that we can meet the innovation landscape where it is, ensure the fact that as the science and diagnostics and treatments available that can impact newborn screening, that the program itself can support that growth. And so you also see on these slides some of the selected proposals, solutions that are included within the white paper. I won't dive too much into those today, but again, in the full white paper, you can find that online. And the second theme was looking at regional lab networks. We talk a lot about the fact that newborn screening is a state program, and at the end of the day, states are the ones who are conducting these screenings, conducting the follow-up, and we need to make sure that they're leveraging that expertise with each other. So the creation of a regional lab network has been discussed. That was an accepted fact within these roundtables, that we need this collection of labs that are interacting with various states across the country and determining how best to leverage that expertise in terms of conducting additional pilot studies, ensuring the fact that we have potentially one lab focusing on how best to implement a certain condition, and ensure the fact that we are adding them as quickly as possible. So the next theme we're talking about is increased access to public data. And so within the newborn screening community, there's a lot of data to be collected around false positives, false negatives, the impact of newborn screening on families, and ensuring the fact that not only are we collecting a uniform version of that data, but that it's publicly accessible. And so there's some work that's beginning within CDC with the EDEN project, which does a lot of this, so I encourage people to read more on that. But it would really build on that and ensure the fact that it is going nationwide. And lastly, I want to talk about theme 4, this idea of integrating genetic testing within newborn screening. I had said before in terms of the importance of making sure we had multiple perspectives. Within this theme, when talking about it quite frequently, we had state lab directors who said, we would love to do more of this. We think this can dramatically improve newborn screening. We just don't have the capability. And so you can say, add genetic testing all you want to the screening process, we just can't do it. And so this idea of ensuring the fact that when we're talking about integrating genetic testing into the newborn screening system, that we're doing it in a way that is a value add, that will truly improve the system and ensure the fact that we're not creating new disparities across state lines if one state can add genetic testing to their newborn screening program and another cannot. And so I know I have moved quickly through the 4 themes, but in terms of where do we go from here, I think it's important to note a few things. First, the challenges we talked about today are not the only challenges of the newborn screening system. There are workforce challenges that impact the entire healthcare system that also impacts the newborn screening system. There are challenges within the follow-up system in terms of inequities and the ability to contact these families. There are challenges within the pilot studies themselves and the ability to fund and start up these programs. So we were not conducting the roundtables to solve all the challenges of the newborn screening. We wanted to start the idea of, here's a place for us to start. Because as you can see from here, it's been a long 20 years within the newborn screening space. 2003 was the first time we saw a published genome. 2008 was the first passage of the Newborn Screening Saves Lives Act. And after the last reauthorization in 24 is when we saw the first FDA approval of a cell or gene therapy, which we know can drastically change the newborn screening system and the amount of conditions that will utilize newborn screening as a diagnostic route. And so where we go from here is continue to work on the current reauthorization, because as you can see on the bottom of your screen, the current Newborn Screening Saves Lives reauthorization has remained unauthorized. And so we want to continue to work towards that passage, as well as begin a conversation of what additional policies are needed to ensure that newborn screening can continue to grow and continue to remain one of the most successful public health programs in this country. Thanks so much for your time, and I'll pass it.